In example 2.9, we're supposed to find the resultant of a group of parallel forces. The resultant of a parallel force system is very easy to find. The first thing that you need to do is simply sum up the forces in the system. And again, you assign either a positive or a negative depending upon if they go up, down, right, left. So in this case, I've got the 5 kilonewton force going down, the 8 kilonewton force going down, and the 3 kilonewton force going up. So negative 5, negative 8, and a positive 3 yields negative 10 kilonewtons. Now again, that negative just really means downwards. Okay? Doesn't really mean much more than that. The second thing that you want to do is you want to figure out, you want to choose a point of reference and see what the real forces do about that point of reference relative to a moment. So if we chose this side of the beam and then we said, hey, let's take a moment about that point, we would have 5 newtons times 3 meters. And again, clockwise typically is going to be positive for us. We'd have 8 newtons times 7 meters. Again, clockwise is typically positive. And then we'd have 3 newtons times 11 meters. That's going the opposite way, so I'm going to say negative. You can add up those moments and you get a positive 38 newton meters. All right? So we know how the forces act. We know what moment they create. So if I use this same point of reference, I can figure out a distance away from that point that the resultant acts simply by taking the moment, 38 newton meters, divided by the force, 10 newtons, and that's going to tell me that the resultant acts 3.8 meters away. So this resultant force that would take the place of those would be 10 newtons acting down at a distance away from that point, 3.8 meters.